Thank you, everyone, for giving me the opportunity to present the work we've been done on the IDS standard in the past 3 years. The purpose of my presentation today is to lay out some foundations for how IDS could support workflows in proof-of-work automation in smart contracts within the blockchain infrastructure. The main point of my presentation is actually to introduce the technology in this domain, in this specific domain, so that I hope to gather some engagement from some of your members and have them help contribute to developing the schema that we have developed. Okay, so I will start from an integration perspective. So the idea is that we need smart contracts in some way to be triggering transactions. And traditionally, we can call those events like proof of work. So there is some evidence that a transaction has reached maturity because some particular events happened. So when it comes to building information model, it would be reasonable to have this triggered by model-specific constraints. However, the construction industry lacked an adopted standard, like a widely adopted standard to capture information requirements. We're starting to gather some reasonable experience in the development of information delivery manuals that, however, define these requirements, but these, however, are generally encoded in Word documents and are only human readable. So how do we convert the constraints and expectations and criteria that would act as proof of work into a software that can be executed on the blockchain? In the past couple of days, we have seen some presentations, and they have highlighted how this is sometimes done by specialist blockchain and construction developers. So developers that are proficient in the blockchain domain, but they're also proficient in the construction domain enough so that they can identify model information, extract information coming from models, run some specialist algorithm on those, and evaluate whether they're sufficient and that trigger blockchain events. These can be, of course, quite expensive tasks. The other opportunity, of course, is we just mentioned this a couple of presentations ago, to use large language models to support information delivery manual conversion to code. But how reliable is this? Because we have seen other presentations highlighting how smart legal contracts, they need to be very carefully evaluated before going into production. So the idea of this slide set is that producing a computer-readable IDS format, information delivery specification format, may remove the need for custom code by relying on existing verification assurance. So traditionally, some IDMs have state their needs in sentences similar to the ones that we see here on the left. At this stage, we need LOD 350, whatever that means. All models should be in IFC format. Yes, but IFC formats are known to be conveying information in a completely messy way. No types, no metadata, no appropriate definition of properties. Separate file will contain all stairs. Okay. How many stairs are we expecting? What are the criteria that we have to identify all of them, and so on? And make sure that all objects are classified. We've seen plenty of documents of this sort, and this, we think, is not acceptable, and is not even a good standard starting point for any of the AI AI conversion that we have seen in previous presentations. And so, and on the contrary, we are expecting information to be adequately structured, defining proper and appropriate types, and associated with the relevant information for the various stages of the construction process. So we would like to see information such as there should be at least one boiler. It should be identified within the heating system. It should have the efficiency and measures expressed as a percentage. And it should have a clear identification of its energy source in Uniclass. So a specific information requirement will not only define specific rules, but will also try to attach itself to taxonomies out there or ontologies out there or other forms of classification. So IDS is a computer interpretable XML-based standard that Building Smart has been developing in the past 3 years to define such statement, like to be able to define, to capture such precise statements and assign them and also make sure that those statements are univocally understood from checking engines that can evaluate IFC files and produce an evaluation of their completeness. The project took, at this stage, has been working for 3 years. It had a few chairs over the course of the past years, have been the latest one in this chain, because apparently it's a highly stressful task that burns out people very fast. So, but jokes aside, it's been a very broad effort. We've worked with more than 200 people. We had hundreds of meetings. We have 85 test cases collected between 34 countries, and at this stage we had even before the release of version 1, we had already 12 implementers that supported this. And I think this is the strength of this proposal that have done. Now we have tried to do a very thorough methodology that ensured that we try to follow the Pareto rule, that we could deliver 80% of all the needs of information delivery specifications, but with a very small implementation footprint. So we went through a state-of-the-art analysis, identification of all the current issues of the information delivery manuals, defined a scope that was feasible in a short amount of time, evaluated about 20 different proposals, selected the technology that was a good one, and then improved on it until a formal review process resulted in the publication of version 1.0 that you can all find on GitHub at the address published here. So what workflows are we hoping to IDS to enable? Well, we thought from the beginning that this standard cannot only be something that allows people to say what they want, but also should help the entire ecosystem actually produce that data. So BIM managers have an actionable data model that allows them to define with clarity, maybe simplistically, but with extreme clarity, what information they need. But then information producers should be able to use the same files to automate as much as possible, filling in those data into the models, and also have an accurate and real-time ability to develop to see what percentage completion of an IDS set of requirements they have achieved. Receiving people, like receivers of this information, then they have 100% certainty that the model that they receive complies with the requirements, but also extra features such as ability to extract data from those models reliably, and also stripping out everything that is not required to pass the verification, which improves, of course, on the amount of storage needed, but also for whenever information should not be divulged. So the scope that we have identified to be valuable for this after these exercises were, of course, all the objects in IFC class in the IFC schema with all the attributes, properties, and quantities. We have limited our ability to investigate geometry requirements, so there's like simple properties such as height, width, and so on, but not more complex analytical environments. Certainly materials and a selected set of relations between objects. So these make the scope of what is possible to achieve within IDS. So in the interest of time, I will skip some of the slides, but this is the image that initially stated our ambitions. And I just want to highlight how it was important for us to include other standards of building smarts, for example, BCF as the mechanisms for rectifying whenever validation of the models was not successfully achieved, and also BSDD as a method for improving and getting closer to clear taxonomies and clear ontologies on the models that we're exchanging. When it comes to the schema specifically, an IDS file is fairly simple. It has a header that contains a bunch of information about milestones, copyright, dates, people responsible for it, and versioning, and so on. And then a plain list of specifications, each of which has an applicability condition and a number of requirements. So both applicability and requirements are data-based, so are triggered on the grounds of information on data that is available within the model. And they rely on the same data analytical tools to be executed. So both applicability and requirements rely on what we call facets. And we have 6 facets to identify entities by type, whatever attributes they have, what classification is defined as a relationship within the IFC schema, or extra properties of quantities that might have. We also have specialist relationship analysis facets that look at the relationship between elements and materials, and elements and their and other parts. Oops, sorry, something happened. Can you still see my screen?
Yep, all okay. All okay, Claudio.
I apologize, something happened to my PowerPoint. I can't see it myself. Okay, I'm back now. Just as an example, quickly, a specification has a name and some instructions. It has a applicability clause and some requirements, as we said. And so the applicability identifies the model subset that we are going to test, and the requirements, of course, all the details of the data requested. As an example, an energy simulation specification will be attached to all IFC walls of type partitioning, and will require a thermal transmittance. But particularly, it will require it in a specific property set, given a specific property name, and constraining it on a specific measure type, so that we can enforce all of these tests. What is the power of this technology? Well, mostly I would say that it's the excellent reception that it has achieved in the construction, in the IT infrastructure of our construction industry. At the moment, I checked today, we have 25 different software applications that are capable of writing IDS requirements, and 29 software applications that are actually capable of producing feedback on the compliance of models against those requirements. So how do we then take it from here? Well, first of all, we need to make sure that these checks are reliable. And so it took quite a lot of time for us to, like in the workflow that we've identified before, the idea of producing an IDS and then checking it against an IFC, that IDS files themselves are reliable. So we have developed an IDS auditing tool that receives an IDS files and tells us whether the requirements that are existing within it are actually feasible. Are they reasonable and feasible requirements to fulfill? And then we have a software certification procedure that will guarantee that all the software that actually does the checking returns the same exact results 100% of the time. This was a big challenge, and we are trying to do this through test-driven development procedures, which allow us, but again, these test-driven development procedures indeed depend on the documentation repository that we have been working collaboratively with many people. And so we have added a test development procedure on top of that. So we have our repository runs auditing of its internal consistency and then produces documentation that goes to produce a lot of test cases to certify the software and a lot of verifications to check that the auditing files are always adequately verified. So it's possible in IDS to combine facets to identify all the specification requirements. We invite people to reuse as much as possible of the existing P sets and properties for consistency, to use classification adequately. But these are perhaps conversations that we might have one-to-one with you if you're interested in picking up IDS as a technology. We never want to use the IDS for enforcing design rules or dependencies or translation. We want to keep it simple and avoid the use of small, large sets of OR clauses, so that we don't have a lot of fragmentation of our rules. Make up your mind. Just tell us what you want. Make it clear. In terms of roadmap, IDS 1.1, which is the next version, will help us orchestrate much better level of information I need at various stages of the construction industry. It will incorporate community feedback from first implementers, fix all sorts of minor annoyances, and community feedback. In the longer term, we are hoping to then establish the IDS software certification, develop a common API across all certified applications, and find ways to state model completeness rules more consistently. And of course, integrate with IFC 5. When it comes to the blockchain uses, I think IDS allows us to simplify and perhaps allow the use of proof of work at design stage, so that when designers provide reasonably complete models, then proof of work is accepted, and they get their fees paid automatically. Again, similarly at construction stage, when you have we have seen blockchain used frequently to with drones and other sensing technologies to see that the models that the products were actually installed on site. But then that's not the real final element that is needed. We also need to upload digital twins models, as built models, with all the required information for proof of work to be completed. It can also provide quality assurance on information, on the existing information, to trigger AI workflows that we've seen before. And we think that it could be a very important element for standardizing a supporting infrastructure that can be used on off-chain oracles and also zero-knowledge proof dynamics. And that completes my presentation. I remain available at these addresses for any queries and to help you come join the development group. Thank you very much.